Hello everybody. So in this section, we will do the same problem here, but by using the mouse instead of using the table entry. And in order to do this, we need to start RISA 2D. Okay, as I said, I'm using the demo version, but the demo version is very similar to the professional version. It is suitable for teaching purposes and for homework purposes. There are some limited options that are restricted, in addition to the limited number of elements and nodes identified here in this front screen. So I will say okay. And we can find here that we have the main screen that I talked about before, and we have also the grid. And we will use the grid to locate the exact location of the joints. And if we return back here, we can find that we are using metric units. So I have to change this to the metric unit system. And to modify the grid, I need to know the distances between the grid lines. So we need grid in vertical direction and the grid in horizontal direction. The grid in vertical direction will have distances equal to 4 between A and B, 2 between B and C, 3 between C and D, and another 3 between D and E. And I can do this by going to modify grid. And here I can start to input these distances. So I will put 4 meter, comma, 2 meter, comma, 3 meter, comma, 3 meter, comma. And for the Y direction, I don't need I need just just one grid or two grids. So I will put distance equal to 1 meter. This will make no difference for me. And I will say okay. So now we have the required grid for us. So you can draw your structure on this bottom line or on this top line. This will make no difference. And now we will start to draw the 25 centimeter by 50, 25 by 50 centimeter by centimeter sections. And to do this, I will go to the draw new member icon here. And I will select concrete. And in the concrete, we have two options. You can pre-assign section. I talked with you about this before, or we can assign shape directly. I will use assign shape directly. And in assign shape directly, I will go to concrete here. And in concrete, we have two options, the circular section and the rectangular section. I will use the rectangular section, and I will select the width, the depth of the section to be 500 millimeters, and the height, the width of the section to be 250 millimeters. Okay. And the material for sure is concrete. You can use any concrete as long as we are not doing design. So any kind of concrete will be okay. And the type of section will be beam. This also very important for design and some some advanced options. So I will select apply. Okay, and now we can start to draw these elements. Okay, so as we said before, you can show the node number by using this icon here. Okay, you can also show the member number here by using this icon. You have like some options you can show based on the labels, based on the shape, or based on the length. Okay, we talked about this before. So we now have the nodes. We have also the elements also identified. And now I want to assign the boundary conditions. I have roller support here, and I have fixed support here, and I have two intermediate hinges here. The two intermediate hinges not considered as boundary conditions. It should be modified through the draw element screen. So I will click on this again here, and I will select modify properties. And here in modify properties here, you can click on use here. Just click on use this option and select fin and fin. Okay, I want this to make this element behave as intermediate hinge, or simply with two intermediate hinges from each end. So I will say apply and select this. You can see the mark of the intermediate hinge appear here. And now we will go to the boundary condition from this icon here, modify boundary conditions. Okay, and in modify boundary conditions, we need to identify A and B. using roller support. So I will select roller support here and say apply, and I will click on this. Then I will click on this, and I will go to the fixed support here, apply, and I will select the last node or the last joint here. Okay. So we now identified everything. We identified the section, we identified the geometry, we identified the boundary conditions, and the material. What we need now is to identify the load cases and the load combinations. The load cases and load combinations, as I said before, like will be identified using these two icons here or these two tables here. So I will use the icon this time to identify the basic load combination. And the load combination today, I will call them dead loads, something like this, and live loads. Okay. And the dead load, I will give it dead load category, and the live load, I will give it live load category. Similarly, for the load combination here, I will click here, and I will have 1.5 dead plus only 1.5 dead. I have also 1.4 dead, sorry, 1.4, 1.2 dead plus 1.6 live. Okay, 1.6 live. Okay, what else? As we said before, we have 1.2 dead plus point half live. And we discussed this before, guys. So if you return to the last videos, I show you how did I define this. Okay, so here we can select the load case included in everyone here. Sorry, yes, the primary load case here. So I will include the primary load case here. The dead load and the factors will be 1.4, and in this one I will include also the dead load case, and its factor will be 1.2. Okay, and in this one I will, at the same one, I will include the live load with a factor equal to 1.6, and for this one I will include the okay the dead load with a factor 1.2, and the live load with a factor 1/2. Okay, as we said before. Okay, everything is okay. Yes, everything is okay. We have some options, important options that you might need later. Something like the B delta, the B delta effect, the B delta effect. Okay, the B delta effect, it is blurry a little bit today, but it is used for second order analysis for design of steel structures and things like this. We can cover this in our advanced class, but for this class, we just need only these few options. You can also generate the load cases or the load combinations automatically by clicking on this option here, but we don't need this for today. So I will close this. Now we need to identify the loads, and to identify the loads, as I said before, we have point load on the beam here. We have joint load in this joint, and we have distributed load on this beam. So I will go to the point load here. Okay, and I will select the case. The case we have in both dead load and live load. So I have a value equal to 6 kilonewtons dead load at 50%. I will say apply. Oh, sorry. So I need to modify this. Should be minus. Okay. Now, so I needed to apply it twice. in order to reserve the sign. So this was the -6 exist on the dead load. We have also -2 in the live load. So this is also I will do now. I will do this also now. I have -2 in the live load. So if you go to the top here, you can show the dead load and the live load that we have now. And currently we can show the P2, or we can start to identify or input P2, and P2 is a joint load. P2 is a joint load. You can do this through this icon here. And also we have dead load and we have live load. Okay, so we will select the dead load here. Okay, and the value is equal to -4 and -3. -4 for the dead load, so I will put -4 and I will say apply. And this is found on this new this joint here, joint D. Okay, this is for the dead load. I will do the same for the live load. Okay, so now again I can show the dead load and I can show the live load. The last load that we have is the distributed load, this one here. So in the distributed load, I will go to the distributed load icon here, this one. And in the distributed load button or icon, I start to select the input the value. We have also value for the dead load and the value for the live load. We have -6 for the dead load. So the start magnitude will be 0 and the last magnitude will be -6 like this. I will leave the start and end location equal to 0. This means that the load is extended over the full length. So it will be like this. Okay, and this is for the dead load. For the live load, we have -4. So I will repeat the same thing, but for with -4 and live load. Okay, so we can show the loads now based on the load case here. Okay, can show the load based on the load case here as you see. And the last step now, I think to just solve, we put everything, go to solve. Okay, I will select batch solution to solve for all the load steps. Okay, so no combination was marked to solve. I need to go back to the combination here, my combination, and mark all of them to solve. And I will say solve again. So we are good now. Okay, we were able to solve this now. So accidentally, I just removed the marks here from this combination. The combination should be marked to solve in order to be able to solve them. So now we can also go back and show like what we did before to show the results. We start with the reaction, the X and Y and Z reactions. This is for the first load combination. This is for the second load combination. We can also show the magnitude here. So this is for the first load combination here. This is for the second load combination. This is for the third load combination. Similarly, for the internal forces, I don't need this now. Okay, so I will go to the members and I can show now the shear diagrams. Okay, I can show the moment diagrams. And you can show this for all the load combinations. You can also increase the magnitude or increase the scale factor and show the magnitude. Okay, you can also remove the loads. This is axial force, sorry. We can remove the loads from here. Okay, we can keep the graphs from here. Okay, so this graph is for member shear force for the case 1.4 dead load. If you need to control this, you can go to the member here and select another load combination like this. Okay, and as I said before, we can just print this figure by using print and you can adjust the settings of the printing, and you can add description here and say continue. It will be printed to PDF file, or you can print this directly to your paper printer. Okay, so the next problem we will focus on the frame analysis of frames. Okay, before I do this, I want also to show you the deflection. This is very important. So we can go to the deflection here from the same window here. We can go to the deflection. Okay, and go to load combination, select the required load combination and say apply. And please don't combine the figures. So if you're gonna show the deflection, you need to switch off all the other figures so I can see the deflection only. And for the deflection, for sure, you can play with the scale factors here. Okay. Okay. Thank you very much, and see you in the next example.